All right, so you're prepping for a senior software engineer interview, and microservices are kind of the name of the game these days, but it's not just about knowing what they are.
It's about how they talk to each other. That's the real make or break for building systems that can actually, handle the real world.
Yeah, exactly, because at the senior level, it's about thinking through the trade-offs, like what are the implications of using one communication pattern over another? That's where the interviewers are going to really dig in.
Right, right. And we're going to do that today. We're going to focus on synchronous blocking communication. Like,
Yeah.
it sounds simple enough on the surface, but there's some hidden gotchas that can really trip you up.
Oh yeah, for sure. And then we'll look at how going asynchronous can help solve some of those problems. We'll see how this plays out in things like, order processing, fraud detection, that kind of stuff.
Perfect. Let's get into it.
Okay, so the most basic way microservices can talk is synchronous, blocking communication. One service calls another and then just sits there waiting, like totally frozen until it gets a response.
Exactly. Picture this. You've got an order processor microservice. A customer makes a purchase, boom, order's placed. Now, you want to give them those sweet, sweet loyalty points?
Yeah, reward those loyal customers.
Exactly. So the order processor sends a message to the loyalty microservice. Hey, award points for this order. And then it just stops. Everything grinds to a halt until the loyalty service does its thing, sends back a confirmation.
So the order processor is like completely dependent on the loyalty service. If loyalty's down, the whole process is stuck.
Yep. And this feels familiar, right? It's like how we program within an application. You call a function, your code waits until it gets something back.
Yeah.
Same with database queries, HTTP calls, all that. So for teams moving from like a big monolithic app to microservices, this synchronous way might feel natural, comfortable.
Yeah, it's that, oh, I know this kind of feeling.
Yeah, but but in a distributed world, this simplicity can be deceptive. Microservices are all over the place talking across networks.
Right, so that tight coupling you mentioned, where one service is completely at the mercy of another, that can be a real problem.
Huge problem. What if the loyalty service is slammed with requests? Or there's a network blip? The order processor is just stuck. And now you've got to think about like retries, buffering, all this extra logic just to handle that one failure point.
It's a chain reaction of complexity.
Absolutely. And it's not just about the service you're calling being down.
Oh, right, because what if the order processor crashes after sending the request, but before getting the response?
Exactly. The loyalty service might do its job perfectly, send back the confirmation to nobody. The original order processor is gone. So it's not just coupling between services. It's coupling between specific instances of those services.
Wow, that's a subtle but important distinction.
Definitely. And then there's performance. What if the loyalty service is just slow? Network latency, database issues, whatever. The order processor is just sitting there, twiddling its thumbs, wasting resources.
And that slowness can ripple outwards, right? Like if enough requests are stuck waiting, the order processor itself could become overloaded.
Oh, absolutely. Cascading failures. One slow service can bring down the whole system. It's like a traffic jam starting from a single fender bender.
Okay, so let's take this a step further. Let's say we've got a more involved order processing flow. We're talking payment processing, fraud detection, maybe even pulling customer details. And each step is a synchronous call to a different microservice.
That's a recipe for disaster. If any one of those services, or even the network between them, hiccups, the whole thing crashes. Even if everything else is perfectly fine, a temporary glitch in one service can tank the entire order.
And I can see how that many open connections, all waiting for responses, could also cause problems with resource usage. Like too many threads, too many open sockets, the system starts to choke.
Exactly. So you see, while this synchronous approach might seem easy at first, it can really bite you in a microservices world. Fault tolerance, performance, resource management, it all gets a lot harder.
Yeah, the hidden costs of simplicity.
Exactly. Which is why it's so important to understand other ways of doing things, like asynchronous communication.
Okay, so how do we start to fix these problems? Like, go back to our fraud detection example. What if we took that out of the main order flow?
Right. Instead of the order processor directly calling the fraud detection service, we can do things a bit differently. The order processor just emits an event like, hey, new order here, and keeps going.
So it doesn't stop and wait for the fraud check.
Exactly. And the fraud detection service, it's listening for these events.
Yeah.
It picks up the new order information and does its checks in the background without blocking anything.
So the order processor can go straight to the payment service, get that authorized, and the customer doesn't have to wait for the fraud check to finish.
You got it. And you often see this represented in diagrams with a dashed arrow,
Yeah.
to show that it's happening off to the side.
That makes sense. And this has some pretty big benefits, right? First off, the customer gets their order processed way faster.
Absolutely. Lower latency for the critical path.
Yeah.
And if the fraud detection service has a hiccup, the order still goes through.
So the system is more resilient, and each service can scale more independently. No more traffic jam because one car broke down.
Exactly. And it directly addresses those issues we talked about with synchronous calls. Shorter critical path, fewer direct dependencies, less chance of one service taking down the whole system.
It's like taking a detour around the accident, keeping things moving.
Precisely. And that kind of thinking, understanding these trade-offs and choosing the right approach, that's what sets apart a senior engineer.
So to recap, we've got synchronous communication, which can seem simple, but has those hidden gotchas with coupling, performance, and resources.
And then asynchronous communication, which can be more complex to set up, but solves a lot of those problems.
And being able to explain those differences, the pros and cons of each, that's crucial for a senior engineer interview.
You need to know when each approach makes sense. What are the specific requirements, the potential bottlenecks, the criticality of each service?
So here's something to think about. Think of a system you've worked on, maybe a website, an app, anything. Where would synchronous communication be okay? And where would you absolutely need to go asynchronous? What would drive that decision?
Really dig into those real-world examples, because ultimately it's about understanding these communication patterns, knowing how they work, and using them to build systems that are robust, scalable, and can actually meet the demands of, the real world.
That's the real test, isn't it? Making sure things work, not just in theory, but when you unleash them on actual users.
Exactly. That's the challenge, and that's what makes it so interesting.
All right, that's it for today's deep dive. Good luck with those interviews.
Yeah, best of luck. And remember, the more you think through these real-world scenarios, the better prepared you'll be.
Absolutely. All right, see you next time.
See ya.